a function f of x is said to be differentiable at a point x is equal to a if its left hand derivative should be equal to right hand derivative. That means f dash a minus is equal to f dash a plus, and we can write f dash a minus limit h tends to 0 f of a minus h minus f of a divided by minus h. This is equal to right hand derivative f dash a plus, that is limit h tends to 0 f of a plus h minus f of a divided by h. If f dash a minus is equal to f dash a plus is equal to a finite quantity, then function is said to be differentiable at x is equal to a. At x is equal to a. If f of x is equal to greatest integer function of x into sin pi x, then f dash k minus is a question, where k belongs to I such of integers. We want to find left hand derivative, that is f dash k minus, that is equal to limit h tends to 0 f of k minus h minus f of k divided by minus h. This is equal to limit h tends to 0 greatest integer function of k minus h into sine of pi into k minus h minus greatest integer function of k into sine pi k. This divided by minus h. Now, what's the value of sine pi k? Sine pi k is equal to always 0. Since sine pi is equal to 0, sine 2 pi is equal to 0, for any integer k, sine pi k is equal to 0. For k is an element of I. So this term is equal to 0. Then what about k minus h? Greatest integer function of k minus h. That means limit h tends to 0, k minus h is equal to k minus 1. This is our k, integer k minus 1 and k plus 1. So k minus h is a region in the left of k. So the greatest integer function is equal to k minus 1. And greatest integer function of k plus h, that is equal to k. Now we can write this is equal to limit h tends to 0, k minus h is replaced by k minus 1 into sine of pi k minus pi h minus 0 divided by minus h. Now, this is from sine of a minus b. Sine of a minus b is equal to sine a cos b minus cos a sine b. So, we can write this is equal to k minus 1 is taking out k minus 1 into limit h tends to 0 sin pi k into cos pi h minus cos pi k into sin pi h whole divided by minus h. Now, again this term sin pi k of sin pi k is equal to 0. So, this term become 0. Then, the remaining term is k minus 1 into limit h tends to 0. This minus and minus become plus. That become cos pi k into sin pi h divided by h. Okay. Now, what's the value of cos pi k? Cos pi k, here k is an integer, is equal to minus 1 if k is equal to plus or minus 1, plus or minus 3, plus or minus 5, etc. That is, k is an odd integer. Cos pi k is equal to minus 1. And cos pi k is equal to 1 if k is equal to 0 or plus or minus 2, plus or minus 4. That is, k is an even integer. Here k is an odd integer. Since cos pi is equal to cos 3 pi is equal to cos of minus pi. Everything is equal to minus 1. And cos 2 pi is equal to cos of minus 2 pi is equal to so on 1. And we can use our standard limit. Limit theta tends to 0 sin theta by theta is equal to 1. Okay. So, this become, so we can write cos pi k is equal to minus 1 raised to k. If k is equal to 1, this become minus 1. K is equal to 3, this become minus 1. And k equal to 0, this become 1. K is equal to 1, 2, this become 1. K equal to 4, this become 1. So, cos pi k can be replaced by minus 1 whole raised to k. And we add a pi here and a pi here so as to balance. Now, this is equal to k minus 1 into minus 1 raised to k into limit h tends to 0 sin pi h divided by pi h into pi. The value of this limit is equal to 1. So f of k minus is equal to k minus 1 into minus 1 raised to k into pi. That is equal to minus 1 raised to k into k minus 1 pi. This is our left hand derivative. Question. F of x is equal to greatest integer function of x into tan pi x. Then f dash k plus is equal to question, where k belongs to I. Since we want to find the right hand derivative, that is f dash k plus is equal to limit h tends to 0 f of k plus h minus f of k divided by h. Okay. Now this is equal to limit h tends to 0 greatest integer function of k plus h into tan pi into k plus h minus greatest integer function of k into tan pi k divided by h. What's the value of tan pi k? Tan pi k is equal to 0 if k is an integer. Since tan pi is equal to 0, tan 2 pi is equal to 0, etc. so on. So this term is equal to 0. So we can write this is equal to limit h tends to 0 and again k plus h. What's the value of box k plus h? Greatest integer function of k plus h. Limit h tends to 0 is equal to k. So this is replaced by k into tan pi k plus pi h divided by h. This is equal to minus 0. Tan a plus tan b, that is tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a tan b. So our limit becomes limit h tends to 0 k into tan pi k plus tan pi h divided by 1 minus tan pi k into tan pi h. And again the value of tan pi k is equal to 0. So tan pi k into tan pi h, this product is equal to 0. So the remaining term is k and tan pi h. This whole divided by h. So limit, so I am taking k outside of the limit, that is k into limit h tends to 0 tan pi h divided by h. Now using the standard limit, theta tends to 0 tan theta by theta is equal to 1. So here the argument is pi h. So here this is pi h. So I am multiplying the denominator by pi. So as to balance, I am multiplying the numerator also by pi. So value of this limit is equal to 1. This implies the right hand derivative f dash k plus is equal to k into 1 into pi. That is equal to k pi or pi k. Check differentiability of f of x at x is equal to 0. F of x is given x plus fractional part of x plus x sine fractional part of x if x not equal to 0 and is equal to 0 if x is equal to 0. left hand derivative f dash 0 minus is equal to limit h tends to 0 f of 0 minus h minus f of 0 divided by minus h. Here a is equal to 0. So a minus h is equal to 0 minus h minus f of a, that is f of 0. That is limit h tends to 0 f of 0 minus h. So x is replaced by 0 minus h, that is equal to minus h. For x is equal to minus h, that is 0 minus h plus fractional part of 0 minus h plus 0 minus h into sine fractional part of 0 minus h. Right. That is equal to limit h tends to 0 is divided by h minus h. Minus h plus this becomes fractional part of minus h plus minus h. That will become minus h into sine of fractional part of minus h divided by minus h. This is fractional part of minus h. Fractional part of minus h is equal to 1 minus h. So this is equal to limit h tends to 0 h plus 1 minus h minus h into sine of 1 minus h divided by minus h. This minus h and minus h added. So this is equal to limit h tends to 0 minus 2h plus 1 minus h into sine of 1 minus h divided by this h minus h minus h and minus h. This is equal to limit h tends to 0, h and h cancel, minus and minus become 1 plus 1. 2 minus, this time become 1 by h, minus and minus become plus, plus sine of 1 minus h. That is equal to 2 minus 1 by 0 plus sine 1. This is equal, this term is equal to minus 1 by 0 is equal to infinity. So the answer is minus infinity. So left hand derivative does not exist. That means the function is not differentiable at x is equal to 0. If a function is differentiable, then this should be finite. But this is equal to find x not equal to 0. Equal to 0 for x is equal to 0. Find right hand derivative RHD. What is RHD? That is f dash 0 plus. Find RHD at x is equal to 0. So RHD means f dash 0 plus. That is equal to limit h tends to 0 plus f of a plus h. That means 0 plus h minus f of 0 divided by h. This is equal to, replace x by 0 plus h. So this become h plus fractional part of h plus h into sine fractional part of h minus f of 0. F of 0 is 0 divided by h. Okay. So fractional part of h is equal to h. So this is equal to h plus h sine of h. That is equal by h. So everything limit h tends to 0. That is limit h tends to 0, h into h plus h 2h. That is 2 plus sine h divided by h. This h and h cancel, then apply the limit. This becomes 2 plus sine 0 is equal to 2. So therefore, right hand derivative, that is f dash 0 plus is equal to 2. That is finite. But f dash 0 minus is equal to minus infinity, or f dash, that is not finite. Derivative is said to be exist if both f dash a plus and f dash a minus are finite and equal. That means f dash a plus is equal to f dash a minus. This is equal to finite. Then function is said to be differentiable at x is equal to a. X is equal to a. Then the function is said to be differentiable at x is equal to a.